The humble cookie seems both very simple and very mysterious at the same time. Why is it that every website you go to in the world has that little pop-up that says they use cookies? Are cookies an existential threat to your privacy? Or are they actually a helpful tool for developers? Have you ever really thought about cookies and how they really work? Do you know what they can and can't do? Let's dive in and you can learn everything you ever wanted to know about cookies. So what is a cookie? A cookie is just a name-value pair. That's it, nothing more. Keep in mind that the web is built on top of HTTP protocol, which is a stateless protocol. What that means is that every single request sent to the server is completely disassociated from previous requests. The server doesn't know anything about those prior ones. You can imagine that makes some things very hard, like if you wanted to track somebody's session or track an e-commerce cart. That'd be very hard to do if every single request came in was completely new. So cookies were invented as a way to have the server send something down to the client that it could remember and then send it back on subsequent requests so that the server could tie multiple requests together. Cookies can't steal your information, cookies can't execute any code, cookies can't access the file system, cookies can't actually do anything, cookies just are. But like with most things, it depends on how they're used. And so even though cookies themselves can't do anything, if they're not handled properly, they can be used in some scary sounding attacks like cross-site scripting, cross-site request forgery, man-in-the-middle, and session fixation attacks. So let's start at the very beginning. So how do you get a cookie in the first place? You get it from the server, and the server sends it to you in a special header called setCookie. The value of that header is the name value pair that we just talked about. When the client receives that header, it stores that cookie in its memory, and then on subsequent requests, it sends back the same exact name value pair on every request. So let's see it in action. I have this little demo here, and if I go to this cookie page, we can see that the server sends back that setCookie header, and here's the name value pair. The name is demo and the value is 11. And if I go to any other page, I can see that the client now sends the cookie header with that same name value pair and sends it back up to the server. And that's how cookies work. The client saves it and then sends it back on every request. And that's cookies in a nutshell. Although cookies are just simple name value pairs, there are some ways you can control their behavior. There's some additional properties you can set when you set the cookie that control how long they last, when they can be sent, and how they can be accessed. Earlier we saw that the client will always send back the cookie on subsequent requests. So if I go to any other page, the client will just keep sending the cookie. But what happens if I close my browser? If I reopen it, and try to go to any page now, the cookie's not being sent anymore. And the reason is that by default, cookies are session cookies. That means they only live for the lifetime of the browser session. In order to make cookies persist across browser sessions, there's a couple properties you could use. The first one is the expires property. This is a date timestamp of when the cookie should expire. Alternatively, you can use max age, which is a relative amount of time in seconds from now when you want the cookie to expire. You can actually set both at the same time, but if you do, the client will just prefer to use the max age value. You might have noticed that there's no delete cookie header or any other way to remove a cookie, and so in order to do that, you can use one of these by setting the max age or expires to a date that's in the past. Like we talked about, if you don't set anything else, all cookies have a session lifetime only. So if I set a cookie, we can see that the server returned the setCookie header with a name value pair of demo equals 9. And if you look at what the browser stored, you can see here's the cookie and the value, and the expiration is just set to session. That means if I close the browser, the cookie will just disappear. But if I set either the expires or max age property, then the expiration will be set to some future date time, and the cookie will persist until that time, even across browser restarts. So if I set this with an expiration, I have a query string here that lets me set it to a number of days in advance. If I look at that, that forces my server to return an absolute date and time. So this cookie is now good through the 15th of June, and if I look back in the tab, you can see it won't expire until then. Alternatively, I could have set max age, and this one is number of seconds from now. You can see that The expiration date is now 2 minutes from now. If you set both max age and expires, the server will send both, but the client will prefer max age. While the expires and max age properties controlled how long a cookie was valid for, the next couple properties control when the client will send the cookie. The first of them is domain. If you omit this, which is the default, then the cookie can only be sent for the same domain that it was set on. It won't be sent for any subdomains of that same domain. You can set this property, though, to the current domain or any parent domain, and if you do that, then the client will send the cookie for the domain you set and all subdomains. Meaning, if you set this, for example, for Microsoft.com, this cookie would be sent for learn.microsoft.com and Microsoft.com. You can only set this value to a single value, so you can't set a cookie to be valid for more than one domain. By default, all cookies are only valid or only sent by the client for the same domain. So if I get a cookie, you can see that the set cookie header doesn't have any additional property. It means this cookie is only going to be valid for this cookie demo domain. If I try to access a page on a subdomain of this site, I can see that no cookie is sent. The browser did not match the domains. Sub.cookie.demo is not the same as cookie.demo, so it did not send that cookie back. However, if I do set the domain, now we can see that the set cookie header has the domain info, and it is set to the parent domain of this subdomain called cookie.demo. That means that this cookie now is valid for cookie.demo and any subdomains. So in fact, if I go to some other page here, I can see that the cookie was sent because this subdomain matches. And in fact, the browser shows me that this cookie, even though I'm on the sub.cookie.demo domain, is set for the cookie.demo domain. Along with setting the domain, you can also set the path or which URLs within that domain that a cookie will be sent for. If you omit the path property, then the cookie will be sent for all requests that are on that domain. But if you do set the path, then the cookie will only be sent for URLs on that domain that match the path or some subfolder or page of that path. For example, if you set the path to /docs, it would match /docs, but also any subfolder underneath that. It would not, however, match something like /docset just because it starts with the same characters, or something like /learn/docs that has /docs in the path, but isn't at the root. If I set a cookie with a specific path, you can see that the server responds with the set cookie value that includes the path. If I access a page that includes that path, I can see that the client did indeed send the cookie back. And that works for any subpart of the path as well. So this can be any level deep. And the cookie is still sent. However, if I try to access a page that's not part of that path, I can see that the client doesn't send the cookie because it didn't match. The secure property instructs the client to only send the cookie for HTTPS requests. That means it won't be sent along for insecure HTTP requests. Because the cookie is only sent for HTTP requests, it can also only be set over HTTP requests. So an HTTP insecure request can't set the secure property. However, when running on localhost, it's a special domain and it's exempted, so you can set the secure attribute from a non-HTTPS localhost. As you can see here, I'm going to not secure URL. If I try to set a cookie with a secure attribute, you can see that the server, because I've set it up that way, did send it, but the browser won't accept it. It's telling me here there was an attempt to set the cookie with a secure header, but it was coming from a not secure domain, so it won't accept this cookie. I don't have an HTTPS demo for you, but localhost gets an exemption. So if I try to hit this same URL, but via localhost, I can see that in this case, the server still sends a secure attribute, and this time the client will accept it. In fact, you can see that it has marked it as secure. The same site property controls whether or not the client will send the cookie only for same site requests or not. The default value is lax, which means the cookie won't be sent for cases like where there's an image hosted on a different site's domain, but it will send a cookie if you simply click a link from a different site to yours. You can also set it to strict, which means the cookie will only ever be sent for same site requests and never sent for any cross-site request. You can also set it to none, which means there are no same site restrictions and the cookie will always be sent for any request, same site or cross-site. However, since that's more permissive, you also have to set the secure property if you're going to set the none property for same site. The default behavior of the same site attribute is lax, but you can also set it to strict or none. But if you set it to none, be aware that there's some other requirements. If I try that, I can see that even though the server sent the same site none, the client is complaining because same site none also requires the secure attribute to be set. So if I try that, it'll still complain because even though I'm now sending it, now it's telling me that I can't set the secure attribute on a non-secure domain. So if I get around that like I did before by using localhost, you can see that now the server sends a secure attribute, it's accepted because I'm on localhost, and the same site none attribute can be applied. So far we've seen other properties that control how long the cookie is valid for and when the client will send the cookie along with requests. This last property, HTTP only, controls whether or not JavaScript can access the cookie or not. The cookie acts and works just like normal, but it means that JavaScript can't access it. This is mostly used to prevent cross-site scripting requests since JavaScript can't even see the cookie. One caveat of this means that if you use something like fetch on the client side, you can't access the set cookie header directly because that would allow you to bypass the HTTP only preventions. I can also set a cookie with the HTTP only attribute. When I do that, you'll see that the set cookie header includes the HTTP only attribute. The browser has now marked that cookie as HTTP only, which means that the client will restrict access to this from JavaScript, so JavaScript can't read this cookie, which is useful for preventing cross-site scripting attacks. All these additional properties control when the client will send the cookie back to the server. When the cookie is set by the server with the set cookie header, all the additional properties are sent down to the client. But when the client sends the cookie back to the server, in the cookie header, all that's sent is the name and value. All the additional properties about the domain and the path and the expiration don't get sent. That means on the server side, the server can't verify that the cookie was actually set over a secure connection or set for the correct domain or set for the correct path. So in order to solve that, there's something called cookie prefixes. Unlike the properties we've seen so far, those control when the client will send the cookie to the server. Cookie prefixes, though, control if the client will even save the cookie at all. If certain conditions aren't met and these prefixes are used, then the client will ignore the cookie and won't even save them at all. The first one is the __ secure prefix. And if you set this on your cookie name, that means that the cookie must also have the secure attribute set, or else the client won't accept the cookie and won't even save it. The more secure one, which isn't __ secure, is __ host. If you use this prefix, the secure attribute also has to be set, but the path has to be set to just /, which means all paths, and no domain property can be set. Essentially, that means that this cookie is locked to the host domain and can't be used with any other subdomains, along with requiring the secure attribute. This allows the server to know if it gets this cookie back that this cookie was sent from the set domain and was set over a secure connection. We learned that cookies are set using the set cookie header from the server, but cookies can also be set from the client in JavaScript. You can both read and write cookies directly from JavaScript. If you want to read the cookies, you can use document.cookie. When you access this, you'll get a big giant string with all the cookies available for this domain. Note that you'll only get the name value pairs though, not all the other properties. If you want to create a cookie, you also use document.cookie and you set the name value pair. You can also set any of the other properties with the exception of the HTTP only property. HTTP only means cookies aren't accessible via JavaScript, which means they also can't set them either. Perhaps confusingly, when you read from document.cookie, you get a single string that contains the name value pairs for all the cookies that match this domain. But when you write to document.cookie, you're actually creating a single cookie. And if you read from it again, you can see your new cookie was set. When you set a cookie, you can also provide the additional properties. Then you can see that those cookies were all set in the browser's memory. They will also be set when you make any request now, just like a cookie that was set by the server. Speaking of the client side, cookies can also be sent with fetch calls. Sending cookies or not is controlled by the credentials option, and it defaults to same origin, which means for fetch calls to the same origin, cookies will automatically be sent. If you want to send cookies to cross-origin requests, you have to set the credentials option to include. But if you do that, since it'll be a CORS request, the access control allow origin header can't use a wildcard and has to have the specific domain that you're sending the request to set. If you don't want to send cookies at all with your request, you can set the credentials option to omit and no cookies will be sent at all. Note that in all these cases, the credentials option also controls the browser's behavior when accepting cookies. So if you set it to omit, not only will cookies not be sent, but any cookies returned by the server will also not be set. A couple other things to note about cookies. Both the name and value are restricted as far as what characters they can include. The name is more restricted and can't include any special characters, mostly just ASCII numbers and letters. The value can contain a few more characters, but is also bound by general HTTP header rules, which means it can't contain semicolons and a couple other characters. You can, however, put double quotes around the value, but that means you can't include double quotes in the actual value itself since there's no way to escape it. If you do want to use any of those special characters in the value, you can use URL encoding, otherwise known as percent encoding, and then you can include any of these special characters. So there you have it. You learned almost everything there is to know about cookies, but there's still a little bit left to learn. First, get your ingredients together. You're going to need flour, baking soda, salt, a couple of sticks of butter, vanilla extract, sugar, and brown sugar. You're also going to need a couple of eggs, preferably from your own chickens, and of course, chocolate chips. But please don't add nuts. Nuts do not belong in chocolate chip cookies. Start out by preheating your oven to 375 degrees. Get all of your ingredients in order and get a big mixing bowl and a wooden spoon. Add the butter to the bowl, and then add the sugar, the brown sugar, and the vanilla. Mix it together until the sugar and butter have been creamed and form a smooth consistency. Add the 2 eggs and stir to combine. The mixture will be pretty runny for a bit, but keep stirring until it comes back together. Add the flour, baking soda, and salt, and stir to combine. You can do this part with the mixer as well, but my mom did it by hand, and so that's how I do it too. Once you have a nice dough, add in the chips and fold a few times to distribute them throughout. Once you have your dough ready, scoop it out onto a cookie sheet. For this demo I made mine pretty big, but you can make them whatever size you want. Pop them in the oven, cook them about 10 minutes or so, or until they're just not quite all the way done. When you take them out of the oven, let them sit on the cookie sheet for a few minutes and then move them to a cooling rack to finish cooling. Then pour yourself a glass of cold milk, have a cookie or two, and enjoy knowing everything you need to know about cookies.